Class, welcome to today's lesson on ions. By the end of the lesson, you should be able to determine the subatomic particles in an ion, construct a Bohr model of an ion, and construct a Lewis dot electron diagram for an ion. Let's get started. So, what is an ion? An ion is a charged particle. It begins with an atom that gains or loses electrons. Ions are called either cations or anions. Anions are negative ions. A negative ion, an anion, forms when an atom gains a negative electron. When an atom adds a negative electron to its valence shell, its charge, also called its oxidation number, goes down. So adding a negative electron is called reduction because there is a reduction in charge. Now, positive ions are called cations. A cation forms when an atom loses valence electrons. When an atom loses valence electrons and becomes more positive, this is called oxidation. We can remember this with the saying, Leo the lion says grr. The loss of electrons is oxidation, and when we are oxidized, our charge is not reduced, but instead it increases. When we look at our periodic table, you should note that metals tend to form positive cations. And nonmetals tend to make negative anions. You can see the oxidation state is listed in the upper right-hand corner of the element box. The oxidation states indicate the possible charges of the ions in the order in which they occur. So when we look at carbon, the most common ion of carbon is -4, though it can also form a +2 and a +4. When we look at our element box, we can count the number of protons, neutrons, and electrons in any ion. Recall that the atomic number gives us our proton number. So here for iron, we have an atomic number and a proton number of 26. The mass is determined by adding the protons and the neutrons. Remember that you can only determine the mass when an exact mass is given to you. To find the number of neutrons, subtract the proton number from the mass number. Now, to find the number of electrons in an atom, it's always the same as the protons. That's because atoms have no charge, because the number of positive equal the number of negative. Now, the only subatomic particle that changes in an ion is the electrons. Our mass is the same. Our atomic number always gives us the number of protons. The number of neutrons can always be found by subtracting the protons from the mass. Now, the electrons are determined by looking at the charge. If we have an iron ion with a charge of +3 that you can see from the symbol having the +3 in the upper right-hand corner, that means that there are 26 positives but only 23 negative electrons to give an overall charge of +3. We can use the same technique for finding the protons, neutrons, and electrons in an anion, a negative ion. Here we have bromine. Bromine's most common ion is a -1. We know we're working with a bromine with a charge of -1 because the charge is listed in the upper right-hand corner. Notice that when no charge is given, we have an atom. The mass and protons and neutrons are not changed in an ion. To find the number of electrons, we have to figure out how many electrons are needed to give an overall charge of -1. Here we have 35 positive protons. In order to have a charge of -1, we must need 36 negative electrons. By now, you should be able to determine the number of protons, neutrons, and electrons in an ion. Now let's see how we can draw the Bohr diagrams for an ion. The Bohr diagrams for an ion start the same way as an atom. So here, if I'd like to draw the Bohr diagram for the ion magnesium, again, notice how there is a +2 here for the symbol magnesium, indicating we have an ion. What we're going to do is draw the nucleus, and the atom's electron configuration exactly matches that from the periodic table, 2, 8, and 2. But if we want to have a charge of +2, it means we must have lost 2 valence electrons. So you'll simply remove the 2 valence electrons. You can also remove the electron ring. Now, why would an atom form an ion in the first place? There's 2 really important reasons. First, you're going to require opposite electrical charges to have these particles stick together. Since atoms are neutral, there's no reason for them to stick to other atoms to form bonds. Recall that forming bonds always releases energy. Forming bonds releases energy because when atoms bond, they obtain a stable, lower energy, complete valence electron configuration. Let's look again at magnesium. So when magnesium forms its +2 ion and loses its 2 negative valence electrons, it has a new electron configuration of 2, 8. 8 is the maximum number of electrons in the valence shell. So here, magnesium has the same electron configuration as neon. Now let's look at oxygen. When oxygen forms an ion, it can only form an ion of -2 charge. Again, notice how we write the charge of an ion in the upper right-hand corner. Now, oxygen usually has 8 protons and 8 electrons. In order to have a -2 charge, the ion must gain 2 negative electrons. When I add these 2 negative electrons, my new valence is 8. Just like magnesium, when oxygen forms an ion, it has the same electron configuration as neon. What's so special about neon? Neon is one of the noble gas elements found in group number 18. The noble gases are gases that have complete valence shells. Since they already have the lowest energy possible electron configuration, they do not tend to react with other elements. Noble gases are said to have full octets because they have 8 electrons in their valence shell. You should be able to construct the Bohr diagram of an ion. Now we are going to finish by constructing the Lewis dot diagrams of ions. Recall that Lewis dot diagrams only show valence electrons. That's because valence electrons are the only electrons that participate in chemical bonding. Remember when we draw a Lewis electron dot diagram, we begin with the element symbol. We locate the valence number, which is the last or rightmost number in the electron configuration, and we dot 1 electron per side until we have dotted exactly the valence electron number. So let's look at atoms as a quick review first. Carbon has a valence of 4. So when we dot out its valence electrons, it has 1, 2, 3, 4. Notice that none of the dots are paired. The number of lone dots will tell us the number of bonds carbon will form. In this case, carbon forms 4 bonds. Oxygen has a valence of 6. Notice how oxygen has 2 unpaired electrons. Oxygen will make 2 bonds. Aluminum has a valence of 3. Now, when drawing the Lewis dot structure of ions, you will have to include the symbol in square brackets and place the charge outside in the upper right-hand corner. This will indicate that your diagram represents an ion and not an atom. Positive ions form by losing electrons. Positive ions will have no electrons in their Lewis dot formula, while negative ions will have 8 dots, representing a full valence shell. Ions never form by themselves. So here, when a sodium ion loses 1 electron, it is gained by a chlorine ion. Let's see if we can apply this with an example. Let's begin with potassium. Potassium usually has 1 valence electron when it is an atom. But I would like to draw the Lewis electron structure for potassium ion. Potassium has a +1 charge when it is an ion. Notice how we have +1 here in the element symbol. So that means potassium will lose 1 negative electron. That means potassium will lose its Lewis electron dot. Make sure you place the charge outside the brackets. How about sulfur? Now, here we're going to do the sulfide ion, which has a -2 charge. Sulfur atoms have a valence of 6. But when sulfur has a -2 charge, it has gained 2 valence electrons. So its new valence is 8. We'll have to add in 2 more valence electrons. To show that we've added in the electrons, we'll put the charge outside the square brackets. Oxygen also has a valence of 6. Oxygen atoms have 6 dots. When oxygen forms a -2 ion, the only charged ion it can form, it does so by gaining 2 negative electrons. The valence changed to 8. Make sure you have 8 dots. Place the charge outside the brackets. By now, you should be able to construct the Lewis dot diagram for ions. This concludes the lesson on ions. Make sure you've taken good notes. Make sure you come to class with any questions you have, your Regents Chemistry reference table, and a calculator. I'll see you soon.